Okay, yeah, so I can get started. Yeah, there is an issue with like my main laptop, so bear with me with just the only presentation. Yeah, so for here I'll talk about like from cloud to cloud, like we can make Ethereum proving. So for here, Ethereum proving means like proving like every block of like Ethereum like in real time, like using our ASICs. Yeah, so probably like before that, I'll do some introduction about like Cysic. Yeah, so Cysic, like so here is like the tech stack at least from the software perspective on Cysic. So we are layer one blockchain. We're based on Cosmos CDK, and we have like the POS and POW like in Cysic, and on top of the consensus layer, like we have the execution layer, which we have a lot of like computing providers, say the GPU providers, like you can also plug in your phone to contribute your computing power to Cysic. And then on top of that, we have this like ASICs, the GPU servers and the mining rigs there. On the top is our products. So we have the ZK Proof Market, ZK Proof Network, and also some AI inference and training, and we have the verifiable AI coming soon. So that's a tech stack on the Cysic like software. Yeah, we are basically expanding the Web3 compute onto ZK AI and also crypto mining. But in addition to that, like Cysic is also, like we started as a hardware company. So like our initial goal is to using some specialized hardware to accelerate the proof generation for ZKP. So like our tech stack is coming from like silicon to blockchain. We have some software component, as I just talked about. The blockchain from, we do some CUDA engineering, and we have some mobile developments. And in addition to that, we also tap deeply into the hardware space. We have FPGA board and ASIC design there. So that's some like brief intro about like Cysic. So for here, like let's talk a little bit more about the real-time proving of like ETH blocks. So for the ETH proving, like it's initiated by I guess like by some like our audience here on the ETH proof. So what is the ETH proof? So ETH proof is a for public goods project, like tracking the real time of ETH proving on the cost, on the latency, and also on the proof size, probably on the which ZKVM like you are using here. So right now, I guess we have like several ZKVM onboarding ETH proof, and as you can see right now, the timing is like still probably like in 2 or 3 minutes, but it's based on just one single GPU card, like 4090 GPU cards, I think. But if you use a lot, say probably like 1 to 200 GPU cards, then you can achieve real-time proving. But real-time proving is like, say, you can prove like probably like every ETH block in about like 12 seconds, which is a block time. Yeah, so that's some more info about like ETH proof. You can check out their website. It's a very beautiful design website. Yeah, then saying like why real-time ZK proving well matters. Since like it will unlock some like more use cases, like we can have like much lighter clients, and we can have like multi-proof workflows to enhance our like confidence in the security of Ethereum, and also we have this like trust minimized rethinking like for the load who want to join Ethereum. So yeah, so that's why like we are like pushing the boundary. I guess the community is pushing the boundaries for the real-time proving by either developing like more software oriented approach, or like by designing some specialized hardware for that. Yeah, so Cysic, like we have, so like we're right now in testnet phase 3. We have like previously launched like 2 testnets, and in the past we have already generated, I guess like around 10 million proof for the community, mostly for layer 2s. Yeah, so here is like our like infrastructure, like at least for the ZK components. So we have a bunch of like whenever we receive a task from some like external ZK projects, we assign this like task. Like right now, it's in a centralized way. So we assign the task to the provers. The provers, they are running either CPUs or GPUs or even like some FPGAs. Like they are like supposed to finish the task within a time period. If they didn't finish the task, then it will trigger a rematch. So we will assign the task to some other provers. And for each task, we actually assign to multiple provers. So in case any problem, one of them is malfunctioned. And after that, after the proof is submitted to Cysic Network, which is a blockchain, we store all the proof on chain. Basically, our chain can be treated as a DNA layer for this ZK proof. So after the proof is generated, we have a bunch of verifiers, which are also randomly selected to verify the proof generated. So they need to vote whether the proof is valid or invalid. So which means they need to retrieve the proof from the blockchain and also retrieve some necessary data, probably from our RPC load, and they verify the proof. The verification can be done right now on your laptop or using just a cell phone. So right now, all these proof tasks assigning, they are sort of synchronized, but synchronized in a randomized way. You are allowed to contribute your power to Cysic Network, so you can join it permissionlessly. So in the future, we will decentralize the proof task probably using the verifiable random function. So right now it's decentralized and it's efficient in a centralized way, and also reward you can get a lot of credits by contributing your power to Cysic Network. So that's an overview. So as I just said, you can download the Cysic verifier on Google Play Store. You can install it on your cell phone, and then you verify the proof. The verification of a ZK proof usually takes about 15 milliseconds. Probably it will also need 1 second to download the data and also uploading the data. So you can use your cell phone to contributing to Ethereum or to the ZK community. So this is a screenshot of our dashboard this morning. So right now we have about 28 provers. So the provers is just right now is 2-car GPU servers. And for the verifiers, as you can see, we have a lot of verifiers inside. Around 190K verifiers there. The verifiers are here to verify the proof. But as you can see, the verifiers, they are somehow decentralized. But if you want to run a prover, then you need to have some powerful machine to run a prover, which means that they are somehow centralized. And if we move forward to real-time proving, then as I just said, you need this 100 to 200 GPU clusters, GPU car clusters to do it, which is centralized. So that's why we need to probably to make it more decentralized and also to handle some more complicated ZK proving tasks, such as for the ZK ML one, which I assume will be more complicated than proving an Ethereum block. We need to design some ZK ASICs for that. So Cysic, we are also doing the ZK ASICs. We almost finished all the designing, all the coding part for the ZK ASICs. Right now is in the verification. We just want to make sure the thing we develop, they are functionally correct to our spec. So here is some design principles. So as we noticed, the ZK computation is actually dominated by two things. The first is this element-wise operation on the arrays. We treat all the data here as arrays. And second is data layout. We need to reorder the array to make it tailored to the next step computation. So the principle here is we use the ASIC to handle this two kinds of operations, and then we have an embedded CPU such as an on CPU to handle the rest, handle the edge cases. So using the combination of two, we can achieve the high performance of ASICs and also the flexibility for the CPU. So here is a diagram for just a 4x4 P array P standing for processing elements. So in our real chip, we have this 1496 P arrays in just one chip. So here is for simplicity, we just have a 4x4 array. And this 4x4 array, they are interconnected with using this high bandwidth arrays. And the RTO development, we're starting from the small arrays and then we're towards the full array. And based on our estimation, it can prove more than 1.3 million key check functions per second. So that's a lot compared with right now the GPU performance. I guess based on the best performance on the GPU, it can prove, I guess, around like 2,000 to 3,000 key check functions per second. So we are several magnitude, order of magnitude faster than GPU. Yeah, so here is like some more details on the ZK ASICs. So it's an element-wise. So I recall I just said like the ZK, it has two kinds of like operations. The first is element-wise operation, which is this like finite field operation, such as like on Goldilocks, on Baby Bear, or some other finite fields. And second is the hash function, the key check hash function, the Blake hash function, or some Poseidon hash function. And then we have some dedicated cores for the modular arithmetic. The ZK computation here carry out, they are all these like modular arithmetics. Yeah, so we have some dedicated cores for that. And these cores, they share some resources for some complex operations. And the second is data layout reordering operation. You need to reorder your data array to make it like ready for the say the next computation. So here we use a symmetric topology for the data transformation for like higher efficiency in the data like reordering, and it's optimized for high bandwidth like reordering patterns. So like there is like one more trick here. So like the memory here we use is like 3D stacking memory. So compare with a traditional memory, which is just alongside with your computing score, the 3D stacking memory is on top of your computing cores, which will make the bandwidth like way much faster. And the bandwidth usually is a bottleneck in the ZK proof generation. So that's just one more like secret sauce in the performance, in the high performance of our chip. And using this like two chip, we will have, okay. Yeah, using these two chips, we will have like two like products. The first one is called ZK Air. It's a very simple machine. It's the size of a proper like a MacBook charger. You can carry it around, and you can use it to prove like every block of Ethereum just using this like tiny machine. And then there is the ZK Pro, which is a more powerful ZK proving rig. We hopefully it can be very helpful in doing some like the ZK ML kind of stuff. Yeah, so those will be the two products of our of Cysic. Yeah, that's all. Yeah, thank you.